time any element from in between also, if it is asked, you should be able to tell we are talking about which element. Suppose we will take a simple example, atomic number 11. What is it? Quick. Yes, it is sodium. Na, right? As we have said, it is atomic number 11. Okay. So, the first thing if you have done, you should now move on to the next. That is, how will you write the electronic configuration of this? How do we write the electronic configuration? You should know that first shell has 2 electrons. Rest shells will have 8 electrons each. Okay, just remember this small thing. First shell 2 electrons, rest shell 8. So पहले shell में we fill the 2 electrons. Now how many remain in this? 11 minus 2, 9. But in the next shell I can fill only 8. Now 10 over. How many are left? The next one has to go in the third shell. Okay, so this becomes the electronic configuration. Always first shell 2 electrons, next 8, whatever remains goes to the next, and whatever remains goes to the next. Chlorine. Yes, atomic number, quick, 17. Now first shell 2 electrons. Okay, second shell 8 electrons. 10 over. How many are left? 7. The third shell can have 7 electrons, so they get filled in the third shell. Okay, children. Now, a little twist here is for calcium and potassium. Potassium, atomic number 19. Okay, first shell 2, second shell 8, third shell 10 over, third shell 8. As I told you, the first shell will have 2, next all will have 8. So, how many over? 18 over. The next goes to the last shell. Right? Calcium, atomic number 20, 2, 8, 8 and 2. Right? We will take one non-metal also. Nitrogen, atomic number 7, 2 and 5. Right, children? Now, the second step also, if you have learned how to write, then you should be able to do the next part, that is to find out the valency. Now, what will be the valency in each of these cases? How do you find out the valency? Ab valency, what it is? It is the combining capacity. Matlab, what will sodium do to combine, and why will it combine? You know that it combines to get the noble gas. Any atom, any element, it combines so that it reaches the noble gas configuration. It reaches octet. Right? Octet or duplet. When do we consider duplet? We consider it for the cases like lithium, all those which are near to helium. Lithium हो जाएगा, then beryllium, boron, all these are near to helium. 4, 5, 6, 6 will be carbon. Carbon is a different case. It shares electrons and then it moves on to the next. So these three at least they follow helium. Okay, so if we talk about the octet rule, they all want that they should have 8 electrons in their outermost shell. यही है octet rule. Every element wants that it should have 8 electrons in their outermost shell. मतलब या तो outermost shell को ये वाला बना दो, that the outermost shell should have 8, or the outermost shell which is already existing should have 8. Like sodium wants that whatever is the outermost shell of sodium, it should have 8 electrons, right? So what will it do? It will remove this. Okay, it will remove this because it should either take up 7 electrons or remove this one electron. So which case is easier here? This one. So it removes one electron, Na minus electron. Okay. Now if one electron is gone from here, matlab from a neutral atom, one negative charge has gone. We know that sodium in its nucleus, protons will be how many? 11, hai na? After giving one electron, how many electrons remained here? Only 10. So protons 11, electrons are only 10. So we have an extra positive. That is why sodium after giving an electron becomes Na positive. Okay, but this Na positive definitely has the configuration of a noble gas. It is more stable. Okay. Chlorine, it will take one electron, right? So because giving 7 will be easier or taking 1 will be easier, obviously taking 1 will be easier, so that this becomes the outermost shell and it can easily have 8 electrons. So chlorine will take one electron. Now when it takes one, so beta proton, how many protons were there? 17. And when it takes one, this becomes 8. And so this total number of electrons become 18. So it has an excess of 1 electron. So this becomes chlorine negative. Okay. So if we talk about the valency, for all these it can be calculated in the same way. If we talk about the valency, sodium's valency is 1. Okay, plus 1 because it will give 1 electron and acquire a positive charge. Chlorine valency is minus 1 because it will take 1 electron. So those elements which have a positive valency, that means which give electron, even this will give 1. So valency will be plus 1. So those elements which give electrons, this will give 1, this will give 2, plus 2. Such elements which give electron are metals. For if we take example of nitrogen, if it wants to acquire 8 electrons, it will have to take 3. Okay. Now in order to take 3 electrons, that means it will have an excess of 3 electrons. Correct? Minus 3 it will have. So those elements which take up electrons, they are non-metals. We have discussed one here also, chlorine, children. Taking electrons, this is also taking electrons, charge is negative, non-metal. Okay, so we have learned how to find out the valency. We have learned how whether it is a metal or a non-metal also. This is very important. Okay, now for all the elements from 1 to 20, you should be able to find out this. What should you do? Elements. Okay, you do one thing. Elements in serial order, elements 1 to 20. Then symbol. Okay, then you will write the atomic number, right? Then you will write the first thing, that is atomic number ho gaya hai. Sorry, atomic number will be this only. Elements, atomic number you can add. Okay, so you can here write the electronic configuration. Okay, the second step. So once you write the electronic configuration as the third column, the next column will be your valency. Okay, and after writing the valency, you should be able to write whether it is a metal or a non-metal. Fine. 1, 2, 3, 4, 5. For 1 to 20 elements, you should be able to classify them in this order. Okay, for 1 to 20, you should not see your textbooks for this, right? You should be able to solve this. If anyone has doubt in any of these columns, please ask. There should be absolutely no confusion in all these, okay? And once you are done, then we will further proceed to chemical bonding, because children, chemical bonding, this part of the chapter has a major role in understanding how and which type of chemical bonding is taking place. As you would be knowing, there are two types of chemical bonding, children. One is electrostatic or ionic, and the other is covalent. Okay, so I will give you the details of it, but I want everybody to be very thorough with this. And children, this you have to do in your fair notebooks. Okay, so till wherever you have done, do it on the blank sheet, right? All this elements 1 to 20. Okay, you can do it in this order only, same way. Okay, so this will be your homework for today, and do it very diligently. You may, if you do not remember 1 to 20, do revise it once before writing it down, but there has to be absolutely no book opening while you complete this table. Once you are done, you may send the pictures to me, or you can check it from the textbook also, all of these, right? So all the best, children, because I really feel this is very important and you should all be able to do it. Okay.